Hi, here's my tutorial for our upcoming quiz on geometric figures. And we're going to get started with number one. I'm going to bring this in a little bit tighter. Oh, you know what? Actually, I think what I'll do is I will refocus and just zoom in. Yes. So the figure shows a scale drawing of a room, and each square stands for 1 square foot. What is the area of the room in square yards? So what we need to know is, first off, a square foot and a square yard. Uh, so what we need to know is that 1 yard is equal to 3 feet. Okay, and um, so 1 square yard is equal to 9 square feet. Okay. Why is it 9? Because if you have 1 yard, so if this represents 1 yard and I make a square out of this 1 yard, like this. Okay, so that's a square, and this is 1 YD, 1 yard. But if 1 yard is, so this would be 1 square yard. And if 1 yard is 3 feet, then if I divide this into three, like this, hopefully kind of three-ish equal spots, but you can use your imagination. And then I divide this into three equal parts. I have, and so this is 1 foot, 1 foot, 1 foot, right? 1 foot, 1 foot, 1 foot. This is 1 square foot. Oof, I had a hard time fitting that in. And so that 1 square yard is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 square feet. So that's how that gets done. Okay, so let's count uh, how many um, how many square feet we got in here. And I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 by 1, 2, 3, 4, 5, 6. So 14 times 6. So 14 times 6 is 24, 84 plus the other part, 1, 2, 3, 4, 1, 2, 3. So uh, uh, 1, 2, 3, 4, 3. 4 times 3 is 12. So add another 12 to that. So 84 plus 12 would be 96 square feet. I think it's important to say, okay, that's how many square feet I have, but but here I have to divide it by 9. So it would be 96 divided by 9, which is what, 9 going into 96, which is 1, 0, because that's 9. 0, 6, that goes in 0 times. So that's 10 and 6 ninths, which is 10 and, which is 10 and 2/3. Yeah, hold on. Let's make that nicer there. 10. Hopefully, 10 and 2/3. Anyway, so that's A right there. A. Okay, the second one. Now let the figure show a scale drawing of a park with the largest dimension equal to 63 meters. What is that scale? So this whole length here is 63. So this is 63 meters. So that would be, and there's 14 squares, so it'd be 63 divided by 14. So for number 2 here, it'd be 63 divided by 14, And so that means it's 14 going into 63, which I believe is 4 times, and that is 56. And the rest is 7. And I could add a decimal here. Decimal, 0, 4, that should be 5 times. So it'd be 4.5. And how did I know? Because when I look at my possible answers, I don't have 4.5 here. I have this right here. So 1 unit corresponds to 1 unit in the drawing is 4.5 meters in real life. So that would be B. Number 3. Oh, and you know what? So I'll say 1 unit corresponds to 4.5 meters. Double underline there. Okay. Number 3. Let's look at number 3. Number 3 says two sides of a triangle measure 25 centimeters and 35 centimeters. What could the measure of the third side be? Well, the sum of the two sides measure that. So the sum of the two smaller sides need to be bigger than the third side. So all of these are smaller than 35. So that means that 35 must be the longest side. And so that what that means then is we have some length plus it's going to have to be 25 centimeters. That the sum of the two smaller sides have to be bigger than the third side, which is 35 centimeters. So now we go through our choices here. I'll have to zoom out a little bit here to make this nicer. So could this be 3? Is 3 plus 25 bigger than 35? No. How about 6? 6 plus 25 is 31, which is not bigger than 35. How about 8? 8 plus 25 is 33, which is not bigger than 35. So it has to be D, 11 right there. So 11, that means the answer is D. Okay, number 4. Number 4 is this one. I'll come in tight here. A triangle has two sides that measure 5 centimeters and 7 centimeters. What is the following? Which of the following could be the measure of the third side? Select yes or no. Okay, so could 5, 7, and 3. Okay, so for A, 5, 7, and 3, I have A, 5 and 3 is 5 plus 3 greater than 7. And that is yes. What did I do here? 5 and 7 here. So 7 is the longest. And I had to make sure that 5 and 3 is bigger than 7, and that is true. B. So we have 5. So we have 5 and 5 and 7. 5 plus 5 is greater than 7, and that is yes. Taking the sum of the two smaller sides and making it bigger than the third side. And for C, that is 7. So we can take 5 plus 7 is bigger than 7. And I know that 7 is equal to 7, but we just grab one of them. It doesn't matter which one. And that sum is 12, which is bigger than 7. So that would be yes. And for D, it is 12. So now 5 and 7 are the two smaller sides. 5 plus 7 is greater than 12, and that is no, because 5 plus 7 is equal to 12. And there you go. Okay, number 5. Number 5, a store sells towels for 25% off the regular price. The regular price of a beach towel is that, which expression represents the sale price. So it's going to be 25% off the regular price. So what do? We take that regular price, which is X. Oh, Let me bring this in closer here. So what do we do? That regular price is X, and and it's 25% off. So it's minus 25%, which is 0.25 as a decimal, times that. So the price of the towels minus 25% of, remember, of means multiply of the towel. And X is the same thing as 1X. So what do we have here? What it is 1 minus 0.25 or 1.00. Remember, 1 is the same thing as 1.00. So that's really 0.75 times X, and that is B. So it's B. Number 6. Number 6 here is the right rectangular prism below has a square base. What could be the shape of the cross section? Okay, has a check that out. Has a square base. Wow, that is loaded right there. Just checking myself. So we have checking myself. So what could the shape of the cross section of it be? Okay, so could we get a rectangle out of this? Yes. If you sliced, this way, that would be a rectangle. So we have yes for A. Maybe I'll do number 6. Number 6 right here. Number 6, A, B, C, D. Yes, you could get a rectangle as a cross section if you cut right along the side there. A circle, I don't even see how you can get a circle out of that. So I'm calling no on that one. B would be no. And parallelogram, yeah, I believe you can, because if you sliced it oh god, I gotta zoom out because this is getting too hard to get it right in it. So if you go diagonally right there, where it's kind of it's cut like this, then yeah, you can get a parallelogram out of that. So for C would be yes. So C is yes. And for D, a square. Yeah, there's a square. It has a square base. So I would say that, there's a square. And if you go vertically, that D would be yes. So D is yes. Okay, number 7. Which of the following can form a cross section? A point and a triangle. So we have, so which can form a cross section? Can you get a point and a triangle? Well, no, you can't, because it is the intersection of a. Let me get the book here and show you where it is. In Module 8, it says here that cross section. Oof, it's kind of fuzzy, isn't it? There we go. So the cross section is the intersection of a three-dimensional figure and a plane. So you need a three-dimensional figure like a cone, and then a plane is this flat surface here. So that's what we got to look for. We're looking for a three-dimensional figure, a point, and a triangle. Those are triangles, two-dimensional figure. It's a flat surface, and a point is just a point. A cone is a three-dimensional figure. A square and a circle, those are both two-dimensional, and a line and a point, that's one-dimensional, and that's zero-dimensional. So it has to be B. 7 is B, because that's the only one with a three-dimensional. So a plane and a cone, plane and a three-dimensional figure. 7 is B. 7, let me show you here. So 7 is B. Number 8. I'm going to draw a line right here to separate the two sides so I get lots of room. Trying to stay organized here. And number 8. Number 8 is right here. So let's go in tight. And so use the diagram for numbers 8 and 9. So for number 8, what's the measure of angle? This is going to drive me crazy with it. Okay, so what's the measure of angle PVU? So remember, V is the middle of the angle, the elbow, the vertex, and the measure of PVU. So PVU right here. What's the measure of that angle? Well, you can see that this forms an X right here, and these two are vertical angles. So that means that this one has to be 63 degrees. So number 8 is 63 degrees because of vertical angles. Okay, number 9. Number 9 is, we have to use that same figure. I gotta zoom out a bit to get them both in there. The measure of, and I'll erase this here. The angle QVP, so we're talking about this angle. Notice how I just marked that right there. So I'm measuring that one. And PVU right here, they are what kind of angles? So they're either, well, they're next to each other. So they're either adjacent angles or they're complementary angles. So we need to make sure we know what are the measures. Let's see. I know that this is 63 degrees, but I have no idea how many degrees that one is. There's no right angles measured here. If they said, if there was a square here, then I would say, oh, this is 90 degrees, so that has to be 90 degrees. And if this is 90 degrees, then this one's complementary because together they make a right angle. But that's not the case. I don't know what the measure of that is. So that has to be adjacent angles. They are just next to each other. Adjacent. D-J-A-C-E-N-T. Yeah, spelling counts. Spelling definitely counts. Number 10. Number 10. Joey cut a 10, let me zoom in here. Joey cut a 10.5, 10 and 5/10 foot length rope into 6 pieces of equal length. How long was each piece? So it's 10.5 divided by 6. Should be. So let's go with 10.5 divided by 6. That would mean 6 going into 10.5. That doesn't go into 1, but it goes into 10 one time, which is 6. That's 45. Decimal goes there, and 6 goes into 45 7 time, which is 42. And that's 3. I can go another 0. Bring down the 0. 6 goes into 35 times. So it's 1.75. And that would be 1.75. So that equals 1.75 feet. Okay. Yeah, I won't have to put that there. But number 11. So number 11 is this one. A scale drawing for a rectangular parking lot measures 6.8 centimeters by 12.3 centimeters. The scale is 5 centimeters, corresponds to 25 meters. What is the area of the parking lot? Okay, so let's write down the information that we know, starting with number 11. Writing down number 11. We have the scale parking lot is 6.8 by 12.3, 6.8 centimeters by 12.3 centimeters, and the scale is 5 centimeters corresponds to 25 meters. Okay, find the area of the parking lot. Uh, so let's see. We have, I would have to change as we have, well, if we have our scale as 5 centimeters is 25 centimeters. Oh, 25 meters, right? Oh, yeah. No. Yeah, I'm sorry. This is meters. Meters. Then if we have 6.8 centimeters, that's how many meters then? So to solve this, we need to have a calculator. Grab my calculator. Where is my calculator? I got my big calculator. I don't need the big calculator. I just want the small one, which I can't find right now. Well, I'll grab the one off the desk. Okay, so I have this here, and I got to zoom out a little bit here. So we have this, and I'm going to have, what, 25 times 6.8? 25 times 6.8 is equal to that, divided by 5 is 34. So that means I have, and I'll say, what did I do here? I did 25 times 6.8 divided by 5, which equals 34 meters. Okay, so there's one dimension, and then we have to do the same thing for the other dimension. So 5 centimeters is 25 meters. I guess I could write equals there. Equals 12.3 centimeters is what? So that would be 25 times 12.3 divided by 5, which is, let's see, 25 times 12.3 is that, divided by 5 is 61.5. 61.5 meters. So the area is the product of these two numbers. Area is 34 times 61.5, which is, so I already have the 61.5, and I'll multiply it times 34 is 2091 is 2091 square meters. And that's our final answer. Number 12. What does that say? The scale drawing below is the base of an office building. The scale of the drawing is 1 unit is 6 feet. Redraw the scale drawing using the scale of 1 unit is 4 yards. Use the grid above. So 1 unit is 6 feet. So for number 12, if 1 unit corresponds to 6 feet, so this is the drawing and this is the actual, then we need to change it to 1 unit corresponds to 4 yards. So, well, remember back here, 1 yard is 3 feet. So if we have 6 feet, what that means is we have, let's change it to yards. 1 unit corresponds to, that's going to be 2 yards, right? 2 yards. So then what we want is this. And so that means that 1 unit will be 4 yards. So each unit is going to cover twice as much space. Well, let's see. Let's see. How about we go here? How many units are we talking about here? I'm going to zoom in here and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's 20 units here, and then it's 1, 2, 3, 4, 5, 6. There's 6 units there. So if it's 20 units, what, 20 times 6 is 120 feet. And then 6 units times 6 is 36 feet. So we have to keep represent this. This has to stay 120 feet, and this has to stay 36 feet. But now each each of these is 4 yards. 4 yards is equal to what? 4 times 3, which is 12 feet. So if I so if so let's see, that's 12 feet. So if I multiply that times 10 times 10, that would be 40 yards is equal to 120 feet. I hope. Okay, so then we have to keep we oh, right, yeah, that's true, but that's kind of extra information here. What I need is this is actually going to be what? This is going to be a fourth as big, and so it would just be 3 units. So I actually just have to divide this by 4. So 36 I did a whole bunch of extra work here. But basically, if it's 36 feet divided by 4, that is wait, why by 4? 4 yards is 12 feet. So that's how many feet, and then 4 yards is 12 feet. So if I divide this by 12, that would be 3 squares tall. And then if I have 120 uh, feet there, and if I divide that by 12, that would be 10 centimeters long. So so to keep representing 120 feet, I would divide it by 12 because it's 36 feet, and 4 yards is 12 feet. So it'd be 3 tall. So 3 tall, 1, 2, 3, and 10 squares long. So 10 squares long. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right there. And I'll do that. Something like this. There, that's the new. Okay, so we have number 13. A square has uh, angles, a triangle has angles measuring 30 degrees and 90 degrees. The length of the included side is 6 centimeters. Tell whether the conditions form a unique triangle, more than one triangle, or no triangle. Um, well, let's see. If I drew this here, number 13 has angles measuring 30, and the included side is okay. So what we're looking at is we're looking at this side is 6 centimeters, and we have 90 degrees like this. So this is that square represents 90 degrees. And then if this were 30 degrees, would this represent, could you make another triangle with these constraints? Could you make another triangle that's squattier, bigger, smaller, different shape or whatever? And this is the classic angle, given an angle and a side and an angle, side and an angle. Um, no, this is you can only make one triangle. You can't make another triangle given these constraints with a different shape and size. So this is a unique triangle. uh, by angle, side, angle. You'll learn a lot about that in the geometry class in a couple of years. Okay, that's number 13. And moving on to number 14. In the space below, oh, check this out. In the space below, draw a triangle with angles 40 degrees, 50 degrees, and a hypotenuse with a length of 2 inches. Okay, so we need my here. And I'm going to give myself some room here. So we need 40 degrees. First off, I'm going to put a dot. I'm putting a dot right there. That is where my protractor goes right there. And, oh, a dot and a line. We need to have a 0 line right there. There. And right here is where I'm going to put 40 degrees right here. And this is going to be 40 degrees. There. Okay, there's 40 degrees. I'm going to label it 40 degrees. And how about I have, oh boy, I hope that this works. 50 degrees this way? We'll see. Yeah, I better do it. Let's see. Okay, I know what I need to do. The other side needs to be 2 inches. So I better just make one of them 2 inches right now. So you have to start at you have to make the 0 right there. And I have 1, 2. Oh, look at that. That was almost exactly on 2 inches right there. Nice. So that's 2 inches. And then I'm going to make 50 degrees off of here. I'm going to label 2 inches right there. And then I'm going to place this right at the corner right there. And this along the 0. And 50 degrees is right up here. Right there. And so I marked 50 degrees up there, and I'm just going to connect. But I'm not going to go all the way from here to there. I'm not going to draw the full line. I don't need this part. So I'm going to start, I'll put my pencil there. And I'm just going to go start where the line is here at the other edge and do that. And then we have 50 degrees. There it is. Patricia bought a new swimsuit that cost $35. Sales tax is 7.5%. How much did Patricia pay, including the sales tax? So it's number 15. So in or on test, drawing on study guide. Number 15 is we have $35 plus we need to know what 7.5% of $35 is. So it's 35 plus 7.5%. 7.5%. You have to move the decimal 2 times to the left. So that's 0.075. So it's 0.075. 0.075 times 35. So when I do my calculator, I need to think about the order of operations first. So that's going to be 0.075 times 35 is equal to that, plus the $35, plus $35 is this. So this all equals 37.625. And what we need to do is, we're talking about money here, remember? So if we're talking about money, it's 37.63 because it has to be in cents. So that's number 15. And number 16. Number 16. Ooh, I got to go to the other side here. Number 16 is, where's number 6? Oh, here. Describe the cross section of the cylinder by naming its shape. Oh, that's easy. That's just a circle, right? So it's just circle. 16, circle. Number 17. Is it possible for a cylinder to have a cross section in the shape of a rectangle? Yeah. If you cut it vertically like this, you'll get a rectangle. So, yes, if the cross section is vertical. And I'm just trying to, yeah, yeah, I would, let's see, how much space do we have here? I think that would have, I guess that would have to be good enough for now. Explain 17. We're not given much room to explain, so I think that that would be, I guess that would have to be enough. Uh, 17, 18. What is the measure of angle EBD? EBD, EBD. That is this. Notice how I mark that right there. The measure of EBD. Well, this is a straight line, which is 180 degrees, and we take 180 minus 47. So for number 18, it would be 180 minus 47. I can't think of that right now. My brain is already fried. 180 minus 47 is 133 degrees. 133 degrees. And I guess maybe I'll put a little degree right there. 180 degrees minus 47 degrees. Number 19. What is the relationship between ABF? I'm going to erase this here. What is the relationship between ABF, this right here, and ABD? ABD, right here. So we see that we start here, and there's this angle and the other angle, and it makes this straight line in the end. So if they make a straight line together, that means that they will be supplementary angles. Nice. They are supplementary angles. Number 20. Number 20, our last one. All right. So this is Deborah has 6.5 pounds of cherries. She wants to divide them into plastic bags with 1/4 pound of cherries in each bag. Find the number of plastic bags she will need. So it looks like it's 6.5 divided by 1/4. 6 1/2 divided by 1/4. Let's see. Well, you know what I'm thinking? This is how many quarters fit into 6.5. Well, 4 quarters fit into one, and 4 times 6 is 24, and then 25, 26. So in my brain, I know it's 26. But let me show you how I can get that. Also, we can have turn this into an improper fraction. That's 2 times 6 is 12 plus 1 is 13 halves. Keep change this to multiplication and then flip this 4 over 1. Hey, you can cross cancel. Cross cancel these. Divide them both by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. And 13 times 2 is 26. 1 times 1 is 1, which is 26. And that would be 26 bags. And there it is. Holy cow, that's a lot. Almost 40 minutes of review. Thanks for watching.